So Padu, in thinking about the award that you've gotten from ASCE, we had a couple of questions for you. One is,
Sure.
what's the most surprising thing that you've learned in all your years in civil hydraulics?
Well, the most surprising thing is always kind of related with flow separations, instability of shear layers. When you have very high velocity gradients, you get instabilities, and these instabilities are very unpredictable. To give you an example, conventional wisdom is that a vortex formed in a pump intake will be more severe as the submergence is reduced or as the water level comes down. But we have observed in some cases the opposite is true. The reason is the turbulence associated with the flow separations and the instability of these eddies that make the vortex come and go. So they become less persistent, and that makes it so different from what you would normally expect.
Okay. I'm also wondering, what are the biggest changes that you've noticed in the civil hydraulics industry?
Well, one of the major changes that I noticed in the last 15 years or so is the computational fluid dynamics. The CFD, with the availability of CFD, I think people are slowly realizing that there are problems that you can at least analyze initially using CFD. For example, if you have 3 designs and you want to select the best design in terms of hydraulics, you can always go to CFD and look at the flow patterns. And using your intuition and the results from the CFD, you can select the best design. But always a physical modeling would be needed, especially if the problem involves very high flows and complex flow patterns. Then you do need a physical model study in addition.
Okay, thank you. And finally, what additional changes do you anticipate in the years coming ahead?
Well, changes I anticipate are pretty much in line with what we have observed over the years too. For example, I just mentioned about CFD. What's going to happen is more and more people are going to be aware of the reliability of CFD in some cases. For example, with a lot of experimental or physical model data available, you will be able to calibrate some of the CFD programs and come up with more confidence in them. But people have to remember that the physical modeling will still be there because complex flow patterns and the unpredictability that I mentioned before will result in the use of physical model. And one other thing I should mention is in the area of power industry, what happens is with the more popularity of the conventional wind turbine or solar or hydro type of energy production, what's going to happen is more and more interest will be there in these areas. More and more money may be available in these areas. And I could see more research related to these renewable source energy. And on the other one, that is in the case of steam electric type of power plants, what is going to happen is there also you will see some changes because we're not building too many new plants. We pretty much want to extend the life of existing plants. So what's going to happen there will be a lot of problems that you want to solve to make these existing plants more reliable. So I find kind of interesting that the next few years will be more concentrated on improving the performance of existing plants and extending their life, plus renewable energy sources. This is for the power industry. For the water and wastewater industry also there's going to be a lot of challenges because the water has become kind of scarce, and we try to improve our old water supply systems here, in this country at least. So there will be a lot of new improvements needed, and the need for augmenting the capacity of some of these water treatment plants. So that will also result in more work in the area of physical modeling.
Great. Well, Padu, thanks for your insights and for your time.
Thank you.